Exponential growth and decay can be used to describe a lot of really cool things in the real world. Some of them you can already imagine. Growth would be if you had a cell and it divided, and then those cells divided and kept on going, so on and so forth. That would be an example of exponential growth. So instead of getting right to our video notes, we're going to go check out a little video. These bacteria are going to start with 1, and then it goes to 2, and then it goes to 4, and you can see it just keeps getting more and more. And before you know it, at the end of the day, you're going to have 2 to the 72 of these that could take over the world. So how does something like that happen? Well, we're going to take the function y equals a times b to the x, which looks complicated, but really it's going to be very simple. X is just a real number, and b, the most important part of it, is positive. It is larger than 0, and it can't equal 1, and we'll get into that in a second. A is just the original amount. It's what you started with, if you want to think of it that way. And it's not nearly as important as b, which is the growth factor. When b is greater than 1, we have exponential growth. And when b is less than 1, but bigger than 0, we have decay. If b equaled 1, there wouldn't be any growth or decay. You would be staying the same, which is why b does not equal 1. And x, finally, is just time. A lot of the time it's going to be annually, it's going to be in years, but when you're talking about half-lives, it could be in seconds or minutes. So we're going to see, how do you tell whether something is exponential growth or decay if you don't have a graph? Well, again, all we care about is b, so you only need to look in the parentheses. So 5, 6, smaller than 1, so this is definitely decay. 3, it's larger than 1, so it is growth. Do not get distracted by all of these other numbers outside. Now, the only sneaky, shady thing that might happen is when you have a negative exponent. But we know what those are. This is the same thing as saying 1 over 2 to the x. Or we could think of it as, I'm going to distribute that negative in. And if I get 2 to the negative 1, that's the same thing as just saying, let's move that 2 downstairs. 1/2 to the x. Well, now we can see, b is a fraction that's less than 1. This is also decay. That's the only kind of sneaky thing that might come up. So, a little note about b. When you have that written, it tells you what the percentage is, like what the actual growth is or decay. So, if we have something like 0.75, a lot of you can tell that you have decay and that it is a 25% decay. And it's because what's missing from 100? But you could mathematically write it out. You'd write 0.75 equals 1 plus b. And so if I subtract 1 from both sides, I'm going to get 0.25 negative equals b. So you can see that b is negative 0.25, which means it's decay. And you just turn that into a percent, 25% decrease. So in this one, 1.73, you can see it's larger than 1. And you can tell how much larger than 1 is it? It's 0.73, which is 73%. But if you wanted to do all the math out, you'd put this, b equals 1 plus whatever this percent x is. We're going to subtract 1. We're going to get 0.73 equals x. And when you turn that into a percent, it'll be 73%. The reason we had to go through that is because we're going to write it backwards. We're going to be given what is the increase, what is the decrease. How do we write that in a word problem without having a panic attack? Well, if it says increase is 3%, the word increase just means that we're going to be going with growth. So we're going to be saying 1 plus 3%. And remember, it's 0.03. Do not write 0.3. Think of it as cents. You would write 3 cents as 0.03. And that is going to be a 1.03 growth factor. Depreciates means it's a decrease, it's decay. So we're going to do 1 minus 0.17, and we're going to get 0.83. And as you can see, it's smaller than 1. So again, decreases is decay. You do 1 minus 0.12, getting you 0.88. So I think you all know that appreciates would be growth. So why don't you try that one out? We'll check back in class and we'll learn how to graph them together on Wednesday.